Hello, welcome back. In this video, we're going to investigate continuity of the given function 1 over x squared minus 4. And one observation here is that this function is a rational function. You have the top and the bottom side, and both are polynomials in this case. And whatever x makes the bottom 0 would make the function undefined. So we first investigate if the bottom becomes 0. And here the bottom is x squared minus 4. We set that to 0. And conclude that x squared equals 4. And then x should be plus or minus 2. For these values, this function is not defined. In other words, the domain of the function would be anything in between negative infinity and negative 2, and negative 2 and 2, and 2 to infinity. Okay, so we're using the interval notation here. The function is not even defined at minus 2 and 2. So, well, the very first condition of continuity fails. So we can immediately conclude that f is not continuous at negative 2 and 2. So the next thing is, okay, is f continuous for other x values coming from the domain? Well, we have to check all three conditions. Let's say like we have a point C coming from the domain, and we know that C is not equal to plus or minus 2. So here, limit as x approaches C. So C again is not equal to negative 2 or 2, right? Limit of the function, which is 1 over x squared minus 4. As long as the bottom is not 0, and which is what's going on in this case because C is not negative 2 or 2. So this is equal to 1 over C squared plus 4. In other words, we can just use substitution. And which is equal to what? F evaluated at C. Not only f is defined at C, but f of C is the limit value. So that makes the function to be continuous for any C other than negative 2 and 2. So all three conditions of continuity are satisfied. So the conclusion here is that f of x is continuous on the domain, on its domain. All right, that is the end of the video. I'll see you in another video. Bye. If you graph the function by using your TI-84 or any other software, you can, well, if you're using TI-84, punch in 1 over x squared minus 4 for y1, and then you can choose your x min and x max to be any numbers, so that minus 2 and 2 would be in between those. So for example, negative 4 and 4 would be like good fit. On the right of 2, the function values approach infinity, and on the left of 2, the function values are approaching minus infinity. So 2 is a vertical asymptote, as you see, as well as minus 2, because on the left and right, the function values increase or decrease without a bound. In other words, they approach infinity or minus infinity. So that's the end of the video. I'll see you in another video. Bye.